We're now going to look at questions 7, 8, and 9 in this test 4 review. This is where we're going to look at the properties of logarithms. And this question 7 says to use the change of base property. And if you have a calculator, that's really easy. Use the change of base property to calculate this logarithm. To calculate this logarithm, the change of base says that log base 1.12 of 90 is going to be equal to the natural log of what's inside the logarithm, which is 90. So the natural log of 90 divided by the natural log of the base of the logarithm, which is 1.12. So very simply, it's just the natural log of 90 divided by the natural log of 1.12, which we can do in the calculator. So we will do the natural log of 90 divided by the natural log of 1.12, press enter, and we get 39.706. So this 8 will round this 5 up to a 6. So 39.706. All right, 39, yep. So 39.706, and that's all. Let's move on to question 8. All right, so this question says to rewrite this logarithm as a single logarithm. And then, well, let's write it as a single logarithm first, and then we'll get to the second part where it says then calculate the value of what's inside. So this says 3 times the natural log of 4 plus 2 times the natural log of 5. Well, the exponent property says that we can take this 3 and we can move it inside the logarithm as an exponent on 4. So this can be the natural log of 4 to the 3rd power. We can do the same thing over here. This 2 can go inside the logarithm as an exponent on the 5. Okay? So our first thing we'll do is we'll rewrite it as the natural log of 4 to the 3rd power plus the natural log of 5 to the 2nd power. Okay? We're not done yet though. We want to write it as a single logarithm. So we have to get rid of, we don't want to have 2 separate natural logs, but they are being added together. Remember, when we add the natural log of this to the natural log of that, we can do the natural log of this, which is 4 to the 3rd power, times that, which is 5 squared. So this is going to be the same thing as the natural log of 4 to the 3rd power times 5 squared. So we've written it as a single logarithm, as they asked. Then it says then calculate the value of what is inside the logarithm and rewrite the logarithm with this value. All right, so what we're going to do is really all we have to do is we have to calculate 4 to the 3rd power times 5 to the 2nd power. And we can do that with a calculator. We'll just do 4 to the 3rd power times 5 squared. And we get 1,600. So this is going to be the same thing as the natural log of 1,600. And that is what they asked us to do, and that is the final answer. All right, so for question 9, it looks like we're going to do something very similar to what we just did with question 8. It says to rewrite this logarithm, we have 2 times the natural log of 8 minus 5 times the natural log of 2, and we're supposed to write it as a single logarithm. Now we're supposed to do something else. So let's do this first part. We know that this 2 is going to become an exponent on 8. This 5 is going to become an exponent on 2. So we are going to have the natural log of 8 to the 2nd power. Then this says minus the natural log of 2 to the 5th power. Okay. Then it says, then calculate, oh, we didn't do the single logarithm yet. We did the first part. This is subtraction, and we know that a logarithm minus a logarithm, okay, if we do the natural log of this minus the natural log of that, we can rewrite it as the natural log of this, 8 squared, divided by that, 2 to the 5th power. So we're going to have the natural log of 8 squared divided by 2 to the 5th power. So now it says then calculate the value of what's inside the logarithm. Well, what's inside is 8 squared divided by 2 to the 5th power. Well, we know, so let's rewrite this, the natural log of, we know that 8 squared is 64. And 2 to the 5th power, well, you could do that in a calculator, but we learned it, and it's 2 to the 5th power is 32. And 64 divided by 32, well, that's just 2. So the final answer here is going to be the natural log of 2, and we have successfully rewritten this logarithm.